Welcome back. In this video, we will continue with MultiversX JavaScript SDK. In the previous video, we learned how to deploy an example smart contract. This time, we will see how to execute functions on it and how to query the contract. Also, please check all the previous videos because some stuff will be reused here. As usual, I created a new file for this one. Then I pasted all the imports we need here. It will be our setup helpers. Also tools from MultiversX SDK. We need to deploy a smart contract on the DevNet to interact with it. I'll do this in the following steps. For now, let's create a handle for it. We need 3 functions. 2 for executing smart contract endpoints, and 1 for querying the data from the smart contract storage. In our example, we will create a Piggy Bank, deposit some EGLD, and then query the deposited and locked amount. You can review the Piggy Bank smart contract in the GitHub repository. There will be a link in the code. Let's deploy a new Piggy Bank smart contract to interact with it. Check the previous video on how to do that. All good now. We need to copy its address and use it in our code for interactions. We need a small node script to choose between the functions we want to trigger, so let's create it. It is more of a helper here, unrelated to the main topic. Let's add some dummy console logs to our functions and see if they work. It looks good. So when I don't provide the function name, it won't work. And when I give a valid function name, its name is console logged. Okay, let's proceed to our main topic, the interaction functions. Two of them are standard blockchain transactions that call the smart contract functions and pass arguments. The third one is a read-only query on the smart contract. Because of that, I will prepare a common SC transaction function for the two, and the query will be handled separately. The transaction steps will be very similar to those presented in previous videos, so I will copy the same helpers. We need a signer, user, etc. We will also need a transaction factory to pass proper data. Let's see how it looks. So, for the smart contract transaction factory, we use the create transaction for execute method, which is similar to the standard transaction. Still, it gives us the possibility to call the smart contract functions. We need to provide the smart contract address, the function name, optionally arguments, and the native EGLD amount to send if required. The next steps for the transaction are the same as usual, so I'll paste them here. Basically, we need to increment the nonce, prepare the transaction for signing, sign it, and broadcast it. Again, please check previous videos, where it is explained in more detail. Okay, let's use our SC transaction in the create Piggy and add amount functions. For the first one, we need to provide the Unix timestamp in the future. It is the lock time for the Piggy Bank. In the second one, we must provide the native EGLD amount we want to lock in our Piggy Bank. These are programmed into the smart contract. As you remember, you can check it out in the GitHub repository. We can use the arguments as plain JavaScript values because we provided a smart contract ABI file. Otherwise, we would need to use typed value objects from MultiversX SDK. But even with ABI, you can mix these. As you probably noticed, we don't provide any arguments for the second function, but we send the EGLD amount. We pass it as a big int value, keeping the decimal places. The EGLD token has 18 decimal places. It is then caught in the smart contract and locked. It is what we want to achieve here. Okay, let's see if the first two functions do what we want, which is to create a piggy bank and lock some EGLD amount. There is some missing stuff here. Let's fix that. We need to add a custom get ABI function, which is missing. It loads the ABI file, its contents being then passed to the ABI registry. Yep, now it works. We have created a new piggy bank. You can always check the transaction on the Explorer. Next, we will lock some EGLD amount. As you can see, we always call our previously deployed smart contract. You can double check that. We have it in the code. Okay, let's return to our third function, which will query the smart contract and return the amount we have locked in. The queries on smart contracts are read-only calls, and they don't perform a standard blockchain transaction. This is why the approach is a bit different. We will use a query runner adapter from MultiversX SDK. We will pass our API network provider. You can pass your custom providers if you have them, but let's keep it simple and use our standard API network provider. If you need, jump to the first video to learn more about it. Then we'll use a smart contract queries controller from MultiversX SDK. We need to pass previously defined query runner and ABI file contents. With that, we can prepare our query. We use the controller's createQuery method. We pass the smart contract address and its endpoint name, the function that will return the locked amount in our case. A smart contract takes one argument, the owner's address value. As always, you can read the smart contract code on GitHub. Okay, we have our query, and then we need to run it. The same controller has a runQuery method, which will return the response object. We will also need to parse the response object to get the value we want. We can do this with the parseQueryResponse method. We only need to pass a previously defined response. The amount is returned as a big number, so we need to get the value of it, and it will be our locked EGLD value. Remember about decimal places. To bring the EGLD value, divide it by 18, or use some helper tools. Okay, let's see if it works. It should query the smart contract and return our locked EGLD amount. We can also check it on the Explorer. The amount passed in the addAmount function should be the same. Of course, you can call the addAmount function multiple times, so the query will return the sum. It's all good. Okay, so that's all for this part. As always, please check the XDev Guild for more MultiversX resources. Check the Piggy Bank smart contract there, and previous videos in the Learn MultiversX JavaScript SDK series. Until the next one.